Hey, hi Atul. Let's get started. I have started the recording as well.
Hey, thanks, Ram. So, thanks everyone for joining. I'll quickly do a round of introductions and hand it over to the speaker today. So, this webinar is organized by Happy to Help. Happy to Help is essentially a non-profit uh, organization. I want to call it that, but essentially a group of people we're trying to kind of run initiatives. We have the website links. I think Om has already put onto the chat window. So if you guys want to just kind of explore the website, you can see there. And basically, what we offer is you can register as mentors, and there are topics. And if you find something of interest, there are one-to-one, and also we do these webinars as and when we have opportunity to find new people and topics. Coming to the session today, our speaker is Neeraj. Neeraj is a senior designer, uh, developer. He's working with Capgemini. He's based out of UK. Um, so he's been like affiliated with Happy to Help for a while, so he's taken other sessions. So continue to benefit out of Neeraj's, I would say, mentorship. And on a personal note, I know Neeraj for almost 15 years, I guess now, like 10 years
Mhm.
now.
Yeah,
And yeah, and Neeraj is like a very enthusiastic and uh, like a very good long distance runner. So if you guys have anything outside of application monitoring and long distance running, then Neeraj is also your man for that. So yeah, so without taking too much time, I'll hand it over to Neeraj. Neeraj, you want to share your screen and start?
yes, Atul. Thanks. Thanks for the notes. Hello, everyone. Hi. Thanks for dialing in today. So let me share my screen. Yeah, I hope you're able to see my screen.
Yeah, yeah, Neeraj, we can see that.
It's loading. Okay, cool. Thank you. Okay, okay, hi, everyone. So we'll be talking about application monitoring with Prometheus. I'm not sure how many of you have used Prometheus or know basics of it, or you might be using some other tools for monitoring applications. But yeah, so in this talk, I'll be focusing on what is Prometheus, its architecture, uh, how the deployment model would look like, and we'll do some hands-on as well. And feel free to ask any questions in between if you have any time. Okay, so these are the couple of topics we'll be covering. What is application monitoring? So what all we need to monitor, where things can go wrong, how do we set up alerts, and etc. What is Prometheus? Obvious, this is what we'll be focusing on this. So what I'm planning today is to cover a kind of overview session of Prometheus. So I think at the end of this call, you will have I'm sure you will have some better idea of what it is and where to use it, when to use it, and how to use it. Uh, Prometheus metrics, so it has some kind of metrics. So as it is a time series database, so it exposes a metric. There are 4 categories of metrics which I'll be talking about. Its architecture, I'll run through the Prometheus architecture, and I'll also talk about the deployment view, how you can think of deploying Prometheus uh, alongside your API containers, and show me the code. Yeah, that's very interesting part. This is where we'll be doing the I'll showing the code, and so you can easily visualize the previous slides, like architecture, deployment view, when you see the code, right? And then there are some extras which I'll be showing at the end of this call. So okay, so what is application monitoring? So this is I've just taken a kind of example to showcase how However, day to day, API and microservices world, how it looks like. We have some API containers. We have a API running in most of the API running Docker and Kubernetes environments. There are consumers, each API talking to some other APIs, talking to external system. You might have some batch jobs running, and some of the APIs, of course, we have some backend connectivity as well, right? So this is a kind of a typical example I'll be taking, and then we'll see where things can go wrong. There are so if you look at this, if I look at this view is where things can go wrong, I would say anywhere, right? So you can have break here, connectivity between this API container. You can have some issue while connectivity to database. You can have some connectivity talking to external systems. A bad job might be not running. You may have issue with your memory or CPU usage, right? And there could be possibility that container itself has restarted or going to crash loops or some application errors, right? So there are many possibilities of error can happen anywhere, and the way we do handle is like we have to monitor and we have to alert and we have to act, right? So this is all about monitoring. So you do monitor, you set up the systems around your application to monitor, you set up alert, and then when alert you can configure alerts. So if it reaches to a specific threshold point, you alert and you can act before everything goes down, right? So if we look at this, so there are two aspects of monitoring here. One is infra level. So you do monitoring at infra level, like whether you monitor your CPU, memory days, certificate expiry. Container monitoring also is one of the option you can start with doing it. So certificate expiry is very interesting, where we have a lot of we always have certificate installed, and we can set up Prometheus to uh, export metrics of certificates so that we know when they are near to expire, coming to expire, so we can take appropriate action before it goes to expiry date, right? And then we will have then on the other side we have application monitoring, right, where you basically look at your application connectivity between APIs, database. You monitor external systems, how many total number of requests coming to your API, what is the response time, number of errors, and maybe bad job or any other application specific monitoring you want to do, right? So I would say this is how I would think of say monitoring as a whole. Um, you can visualize in terms of application monitoring, right? Any questions? Okay, cool. So let's talk about how Prometheus help us to uh, export metrics out of these, and we can have monitoring and alerting setup. So what is Prometheus? So it is open source monitoring and alerting system. So as a whole, it monitors and at the core of it, it is a pure time series database, right, which basically collects a metric and stores in the time series format, right? And this is in today's DevOps environment, this is a highly dynamic container environment like Kubernetes and Docker Swarm. It's very useful to monitor any of these environments. Also, you can monitor your traditional non-container application as well, right? Its targets can be configured with service discovery or static configuration. So what does it mean is like you can tell Prometheus to tell. I mean, you can configure Prometheus the host and the port where to pull the metrics from. So basically, it works on the pull mechanism, right? So it scraps metrics based on pull mechanism, and uh, whereas if you look at so there are two types of mechanism, push and pull. And if you look at AWS CloudWatch or New Relic, they work on push mechanism. So what it means is uh, uh, with that setup, you would require to run some daemon alongside your application container, which basically push metrics to a centralized location, and from there you start monitoring whereas Prometheus is different in a way that it pulls the metrics. You just configure it and you can tell, okay, I want Prometheus to pull metrics from this target on every 5 second, 15 second, or whatever time you want to set up. It's all configurable. So that's what the target is, and that's what the pull metrics or the pull mechanism it works on. It it stores, as I said, it is time series database, so it stores metrics and time series format with key value pair. So if you look at it, what time series means is simple. It's a simple term. It changes are recorded over time. So for an API, it could be requests per minute. For database, it could be how many active connections at a given time. So it's all about time, and the changes are recorded over time. So it stores everything in a time series database. It works on a query language called PromQL. You might have heard about it if you use Prometheus. So when Prometheus stores data, and you can fetch the data using the PromQL or HTTP server. So that's a very good part of it. You can just query and it will talk to HTTP, and HTTP server talk to the database to pull the data for you. The main Prometheus server runs standalone, so that's the best part of it. Is no external dependencies. It just runs as standalone. Most Prometheus components are written in Golang, and yes, it has joined the Cloud Native Computing Foundation 2016, second project after Kubernetes. So this is pretty much, if you look at it, what Prometheus is. This is at high level, at its core components. This is how it is made up of. Okay, any questions?
Yeah, Neeraj. So
Yeah.
is it going to help us with the front end monitoring also, or just API monitoring?
Yeah, you can perform front end monitoring as well. Yeah, there are some exporters there are some plugins which can fetch metrics from, and then it can be done.
So is it going to be a real user monitoring or synthetic, like if we do so?
Um, I don't know, to be honest, how that would be. I have not used it for front end,
That's
or
so
probably I have not explored that front end. But that's a good question. I
Mhm. Yeah, I mean, if you have used Grafana, so my question was, is it going
Yes.
to be similar to Grafana or something else?
Yeah, so Grafana is visualization tool basically. So Grafana is you can plug in Grafana with Prometheus. So, and the best part of Grafana is it can you can attach any data source to read it from. You can attach to InfluxDB or Prometheus or any other time series database or any other input system. So Grafana is just a visualization tool, whereas Prometheus is a time series database which collects a metric and stores it.
Got it, got it. Thank you.
Yeah, no worries.
So,
One quick
Neeraj,
question.
Yeah.
okay, so basically, does Prometheus have a? I've actually seen some Prometheus UI where I could actually configure
Yes.
alerts and see the metrics in a time series format as well.
Yes.
It's more like
It
an
does have.
dashboard, right? So,
Yes.
is it? Do we use Grafana along with Prometheus only because Grafana offers like richer features in terms of dashboarding, or can Prometheus be used standalone for alerting, dashboarding, etc.?
Yes, that's correct, and that's a good question. So basically, Prometheus has its own web UI where you can monitor the metrics, but it is not that rich in terms of the features, right? So that's why in Prometheus recommends use Grafana if you look at the Prometheus website. So Grafana is very rich product for visualizing the dashboard and etc. It's very powerful tool.
Got it. Okay. And one more question was
Yeah.
this pull mechanism, right, that you mentioned here.
Mm-hmm.
That's interesting. So
Mm-hmm.
actually, does it mean that the applications or the services that it's Prometheus is monitoring now have to expose
Mm-hmm.
those metrics via some API endpoint, or do they actually store it in
Yes.
log and then that is okay?
Yes, yes. So they will have to expose API endpoint. I will come to that section very soon. So I'll show
Sure,
you
sure. Okay.
how to do that. Yes, yes. So in short, yes, they will have to export some endpoint. And if it is not API, if you can also monitor the Linux node itself. There are certain exporters available which
Got
export the
it.
metrics on behalf. So I'll explain that in coming slides.
Sure, sure. Thank you. Yeah.
Cool. Thank you. Okay, good to go next. Okay, so Prometheus metrics. So there are four type of metrics supported at the moment. One is counter. So counter is like it can increase or reset to zero. So you normally use a situation where you want to see how many times X has happened, right? So probably you'll see number of requests served by API, number of errors, number of tasks completed. It is not recommended to use when it is going to for a decreasing value, right? So most counters always recommended we suffix with underscore total, and that's what it then it can easily identify it as a counter metrics. For the situations where things can go up and down, it is recommended to use catch. So it's a value we can go up and down. So you can think of as a speedometer which can go up and down of your car, right? So you can use it like a memory usage, which can go down number of concurrent requests. So it's better use cache at the time. And then they have got histogram. Histogram is like you might have used some GC monitoring tool, garbage collector monitoring tool, where you have like how long this specific process took, right? How big something this was. So that's where the histogram metrics are best to use for. And then we have got summary. Summary is like similar to histogram, but also provides total count of observations. So we will be talking about count in this session. You get a fair idea how count works and how you want to configure it. So these are the four metrics supported. Okay. Any questions? Okay, cool. Let's talk about the Prometheus architecture. So what I've seen this, if I mean, I just grabbed this from the Prometheus GitHub page or website, but that's how it looks like. So if you look at the core component of it, this is the core component where you have retrieval. This is time series database, HTTP server, and this is retrieval is pulling the metrics. Yeah, so it pulls the metrics from jobs and exporters. So there are some exporters. I'll tell what exporters are. The jobs are your APIs, which exporting the metrics. You got short-lived jobs. So basically, it supports a pull mechanism, but sometimes you have some kind of bad jobs, right? So bad jobs, it's like if you configure Prometheus to read from bad jobs, you don't know whether bad jobs is finished or not, right? So in that case, they have provided push gateway. So you can configure batch jobs, and at the end of the batch job, it can simply push a matrix, and then Prometheus can simply pull the matrix from the push gateway. So that is sorry. So that feature is also supported here. And then you got a service discovery. So basically, push Prometheus server has got static configuration, as I said. So static configuration is where you have the Prometheus.yaml setting there itself to identify the targets to read from, or basically you can have service discovery to identify the targets. There are various service discovery patterns available. Um, going back. Okay, then you got prom. If you look at this, there are data visualization and exporters. So it's if you see this is a Prometheus web UI, there's a Grafana, there are some API clients. So these are connected to the PromQL. So you just put a query on this UI, and this query goes to HTTP server. HTTP server goes to database and pulls the data from time series database, and it just go away from there. It just gives the response back. And then you got alert manager. So with the configuration of Prometheus, you can set up the alert managers. You can set up certain rules, and based on the rules, the HTTP server will push an alerts to alert manager, and which can be then configured with any alert system like PagerDuty, email, or there are many other supported. So you can just send out the alerts. If you see this, it stores the time series database in the HDD or SSD. Where it stores in the local hard disk, but you can also configure the remote storage as well. So that option is also supported there. So in the next slide, I'll just focus on the Prometheus server core component. So which is where we'll be focusing main on. So I'll just show you this how it looks like.
One question, quick question.
Yeah,
Like
yeah,
Docker have the API, Docker expose the API for the
yeah,
Prometheus server, but how can we monitor the Linux servers, base
yeah,
server?
yeah. Yes. So
We
Linux
have to
server,
push
that's
the
why.
data.
Yes. So they have got node exporters. So if you see here exporters, right? So it comes with the Prometheus supports some node exporters, and if you run the node exporter on your Linux node, it will monitor your Linux system, uh, memory, disk, CPU, etc. It provides a lot of metrics about your Linux node.
Okay, so we have to run one more application,
Yeah.
the
Yes. You
node
need to.
exporter in the Linux.
Yes. Correct. Correct.
Got it. Thank you.
No worries. Okay. Okay. So these are the core components. So I just zoomed in the core component section. So if you look at this, we have got Prometheus server. If you look at the Prometheus.yaml file, right? So we have got this is a sample file. I'll show you the file which comes default with Prometheus, which has got some other alerting as well. But there is a global config scrap interval 5 seconds. So you can just this is a global. It will scrap the metrics from the targets every 5 seconds. You can override the setting with the job name. So if you look at the job name is there Golang, expose metrics path, and static config. This is static config at the moment where the target is this. Okay, so it will hit this target, go to that endpoint every 5 seconds. It will pull the metrics and store into the database. Right, so this data retrieval worker will pull this container API, and these APIs are using the Prometheus client library for exposing the metrics. So I'll show you in the show me the code section where how you can use the client library. At the moment, it supports Go, Java, Python. I think there is one more. I don't know, but yeah, it supports. There are 4 or 5 client libraries supported by Prometheus, and then obviously once it builds the data, it stores into the database. It then HTTP server is there to read the data or the prompt QL. So this storing into the hard disk, but there is also you can there is a remote storage also supported. So you can tell that okay, I want to store to not hard disk, but I want to support to the cloud. So there are various adapters available to store the data to the remote storage as well. You can also use InfluxDB as well to store your data. Prometheus data. So I mean, this is the core components which plays a major role in pulling the metrics, storing and exposing the metrics or HTTP server. Right. Any questions here? Okay, cool. I'll go next. So I think next is deployment view. So this is kind of deployment view I could think of in a single data center view. So it is recommended that you run Prometheus in a separate node. So if you look at this, I have this Linux node here where my API, customer API running, account API running, product API running, and this data there is another Linux, another node where I'm running a Docker container in Prometheus, which is pulling the data. And if you look at this, it is storing data outside the container, right? Which is obvious. Otherwise, when you restart the container, it will you lose the data. So you have your data storage in the node. Now this is a one view, but you can also run the node exporters here. So you can run another container in the same node, and which will be node exporter to monitor the Linux node. So this will allow you to monitor your Linux node, as well as you're also monitoring your APIs. You're also exposing metrics of your APIs, right?
Is it
And
work for the Windows server as well?
sorry, so again, I missed that.
Is it work for the Windows server as well?
Yes.
Okay,
Yeah.
got it, got it.
Okay. Okay. And then you can have, so this is another, like you can so what is Thanos sidecar, right? So you can run another sidecar, which is another library. It is supported by Prometheus. It is recommended you take a snapshot of, so if you want to scale, right, if you want to scale it out, you can think of it as taking a regular snapshots of your data, and then over the period of time you can run this sidecar, which will pull the data and some object storage or cloud or anywhere. So you can also have this kind of setup to so pull the data, and which is like historical data. You want to just pull it and free up the space onto your node where Prometheus is running. You can also have this arrangement to externalize data after a period of time. And this is all open source. Yeah. uh, so any questions here?
So one quick question about high availability here. I see there's just
Yeah.
one Prometheus server. So for HA, do we actually deploy multiple instances of it and have it like as act as a master slave or something of that sort? Or how does that support it in
Yes, that is supported.
natively?
Yes.
Okay,
Yes, that is supported. So if you can very much scale it out, and you can very much there is a federation model also supported. So you can have if you have two data center, you can run on another Prometheus server on that data center.
got it. Okay, thank you.
Thank you. Okay, any questions here? Let's move on.
One more question. If you
Yeah.
have a
Go on.
Java application, so we have to
Yes.
export the APIs for the Prometheus to monitor that.
Yeah. So if you have Java application, there will be a client library, Java client library of Prometheus, which you can use in your Java code to expose the metrics.
Okay. Same for the Python as well.
Yes, correct. Same for the Python as well. That's right.
Thank you.
Okay, cool. I'll go next. Okay. So let's talk about this installing Prometheus, and this is what we're talking about, understanding Prometheus.yaml, and we'll run an API with Prometheus client library, and then we will look at the metrics endpoint, and then we'll see the metrics on Prometheus web UI. So that's what we'll be doing in this show me the code section. So let me go back. Okay. So let me show you the Prometheus file which comes default. So this is when you install Prometheus, right? This is the default file it looks like. So scrap interval, your evaluation interval. This is evaluation interval is how after how many time it will evaluate your rules file. So there is a rule file here, right? So first rule file, second rule file, periodically evaluate according to the global evaluation interval. So based on the time, it will evaluate the rules file. Alert manager configuration, alert managers, static configs and targets, right? Where you want to alert, when you want to send notification to alert managers, right? And then this is very good documented. Scrap configuration contain exactly one endpoint to scrap. Here is, so when you run Prometheus, it exposes its own metrics by default, and so your job name, static configs and target. So this is how it's file looks like. Right. Okay. So let me show you the code. So this is my API written in Golang, and if you look at this, it is a very basic thing I've done for the demo purpose. If you look at this, I have imported these Prometheus libraries, Prometheus Auto and Prometheus HTTP. Okay, and here I'm using the counter. Here I'm using the counter metrics. I'm just showing the HTTP request total, number of GET requests. This is the name on help. Okay, so name is the type of metric and help is to give you more details about what the metrics type is. I'm just running a Go routine, or you can think of a thread in Java, which is just incrementing after every 2 seconds. Okay, and then you just tell, okay, whenever somebody hits the metrics endpoint, the handler is from HTTP. So this from HTTP is the handler which will handle the request coming over metrics endpoint. Okay, so this is the client library I was talking about. And similarly for Java also, you would have some similar library which you can use and just straightforward expose the metrics. Okay, so for the demo purpose, what I have done is I'm running a Docker Compose. So I'm running 3 containers. One is Golang container. I'm just given a name, which is basically this API, and it's referring to the file where I'm just building the app and doing the stuff, simply creating the uh, build out of it, and it will just exposing 7070. Okay. Uh, Another container I'm running is Prometheus container, where I'm telling, okay, this is my Prometheus.yaml file is located, and this is port is this, and I'm running the Grafana as well, which we'll talk about later. So there are three containers I'm running, and my Prometheus.yaml looks like this, which is here. So escape in $5 and I'm running my local API on this host and port. Okay, so this is how the setup looks like, and so let me start this now. Okay, so we got container up. Yes. Okay, so if you can see, we have 3 containers running here, right, on different ports, 9090, 3000, and 8080. Okay, so let's go and see how it looks like. I just pre-opened it for the quick purpose. If you look at this, this is my product API, which is running here on 8080, just running simple output. This is my metrics endpoint. Okay, so this is how the metrics looks like. This is the metrics which is exposed by my API using the Go client library, and this is the total number of requests. So if you see that, you would have seen there are so many metrics available here, right? So what they are is they are the Prometheus export by default. So it talks about the Go and how many routines are running and etc. etc. So if you look at any of these, the help and type section is very self-explanatory, and it is a simple text file. So if you see Go DC durations, a sum of the pause duration of garbage collection cycles. This is a summary. So if you look at this, this is a summary type of metrics. I showed you in the beginning, there are 4 metrics supported, right? So one is these are the counter, these are the summary, and here here's the gauge, and I'm not sure we have got histogram. It doesn't support by default, but anyway, so that's our product API. Okay, we got this product API running here. The path is this, and total number of requests is 7 so far, which is running every 2 seconds. It is hitting, so it should be increasing, keep on increasing. Okay. So that's how it is. And now if you look at this is the Prometheus. So if you just hit this, this is the Prometheus web UI I was talking about. So this is exactly what is happening is we are running the PromQL, which is going to that HTTP server. and then it is going to TS database times the database, pulling the data and execute it, right? So you'll see the graph is increasing. Yeah, this is my old instance and this is my instance. So this is how it is. Just keep on you're showing the is working, right? So and if you look at it, I have also used Grafana. So this is not part of the demo, but this is what I want to show in extras. So let me edit this. I'll show you how to configure this. So this is the data source. So you just it comes with a panel and dashboard. So this is I created a panel, and then what you can do is you can just say data. What is your data source? It supports a lot of data source. I use Prometheus, and then okay, I'll show you where do we configure the data source. That's easy for it. Data source. Okay, save dashboard. So, okay, so this is the data source. So I'm telling Grafana to talk to Prometheus on this host and port browser, and then scrap interval, and at the moment it is get, you can define other metrics as well, and you can just save and test. So this is the data source where you tell Grafana which from where you want to pull the data
One
from.
quick question. So yeah,
Yeah.
it doesn't support any security mechanism, like Microservices is exposed to the public world.
What? Sorry.
If I want to put some username password authentication before extracting pulling the metric,
Pulling the metrics.
yeah, from the application server or from the Linux server.
Yeah, it does supports from application. So mostly application exposing. I mean, you if you hit application endpoint, they always expect any token, right? They already expect a auth token or some kind of
Yeah.
token to expose. So yes, it supports. So that is where you will have to configure in Prometheus. There are configurations available in Prometheus to when you are talking to API, you can supply the bearer token as well.
Okay.
And
That's
once Prometheus pulls the metrics, we will only be able to pull the metrics when the bearer token is applied. So all those configurations there in Prometheus.
okay. So we have to configure these configuration on the both side, on the Node server as well that we are running on the Linux server and on the Prometheus server as well for talking.
Uh, on Prometheus, basically, yeah. So on Node, you will obviously have some security in place, and API also you will have some security in place which expects a bearer token. That will always be there. You just need to configure in Prometheus
Okay.
before sending the request. So basically it sends a request, right? What it does, it sends a request to metrics and it gets the response. So while sending the request, you can alongside send some bearer token also.
Oh, there is
Right.
one more option, auth, basic auth and credential.
Yeah. Yeah. That's right.
Okay. Okay.
Cool. So this is how you configure the data source. And then when you go home, you go here, you can just see you can just, I mean, you can just see keep on increasing. So if you edit this, what I was showing is you can have metrics. So you can add a number of metrics you want. You can add another query, and if you see here, it will just GC. So if you see here, you have as in a type, it will pull all the metrics from there, right? So it is also pulling the GC metrics which is there. So basically, what I mean to say is whatever you see here, right? You can see all the metrics available in Grafana, which is pretty cool, I think. So yeah, you can just see whatever metrics you want to monitor, a lot of it. So that's there, and then you can configure. There are so many stats here. I mean, you can configure the cache, bar, table, pie chart, whatever you want to see here, right? So time series format, you want to see in stat format, you want to see in cache format, and there is a pattern where you can set the threshold. So you can threshold, okay, at this particular time, I want to set up threshold, and then I want to set up alert. So it can be configured that way. I haven't explored Grafana, to be honest, to that much detail so far, but yeah, I just did some basic panel setup and Prometheus integration. So that's how you can look at it. I mean, you can monitor, you can set up your API, you can set up the metrics, you can you can pull the data in the from QL, or you can integrate with Grafana. Did I have anything to cover? I think visualizing Grafana, and this one I wanted to tell. Yeah. So this is, I think, pretty much all I wanted to cover. I'll just show you some. So yeah, these are the words I was talking about, the service discovery. It supports all of the service discovery patterns: Consul SD config, TRS config, Open SDK, GCE, Kubernetes, and the static config which we have used just now. So there are various this supported. There are some of the links which I was talking about, the remote database integration. So if you, it has very rich documentation. So these are the remote endpoint and storage supported, right? So there are so many of it supported. You can store data anywhere in this InfluxDB. And if you go here, basically these are the adapters I was talking about. So this is Prometheus time series adapters with which you can store the data to external systems, right? Um, and node exporters, yes, I'll just show you the node exporters. Two node exporters. Yeah, so Prometheus has got a lot of node exporter, use 6.6K star, very good. So yeah, export hardware and OS metrics, export by this written in Go, right? The Windows exporter is also recommended for Windows users. So as you asked, I think somebody was asking question, supports Windows 7. So yes, but they have all Windows exporters about it. Installation users, use simply a Docker image is available. You can just pull and run a node exporter alongside, and it will just do the work for you. And these are the metrics supported by default: CPU, disk stats. There are so many of them. You can just frequency statistics, expose disk IO statistics, and there's so many things that supports X exporter. So this was fine. You can have node exporter running on your node to monitor the Linux stuff. Monitoring containers, so you can monitoring the container as well. So as I said, you can also monitor the container to see. So there's a very good library called C Advisor. I'm not sure you have heard about it. It's very good. You can monitor how your containers health actually. So this is container user understanding of the resources, performance about it. It's also, you can run a Docker container. You can just run an image and do the stuff for you. So there is a C Advisor you can use. And yeah, I would say you can have a look at this Prometheus FAQ. There are very good questions covered over here, and it's the very good documentation. So, and yeah, it doesn't scale. Yeah, I was told Prometheus doesn't scale. Very good question, right? Somebody asked the scale. So it has a very good various fact you can scale the federated Prometheus, and there is a very nice documentation here somebody has written. And you can see here scaling federating Prometheus easily handle millions of time series. Yeah, that's enough for 1,000 servers with 1,000 time series each scrapped every 10 seconds. So if there are scalings available, there are with federation model, and initial deployment is also there, right? So it's a good read if you want to have a look at it. FAQ is very good covered. And yes, it is not supported for log. Somebody asked, can I use a logging for it? So log into Prometheus. It is no, because that is not it is meant for. So no, it use the ELK stack instead. Yeah. So it's pretty much very clear in that term, because it is a matrix, not so they're asking to use ELK instead for logs. Okay. There are various other if you okay do any questions, I'm finished. I'll share one very interesting library which you can integrate with Prometheus to do so many things. You can monitor your IO devices, You can monitor your sensors. You can, if you have, you can create your own dashboard to monitor your home networking. So you can monitor your router and see how it is performing. If SNMP is enabled, most of the time SNMP is not enabled, but if your SNMP is enabled on your router, you can monitor the dashboard in Grafana with some library. But anyway, so far, if you have questions, I'm happy to answer.
Hey, hi Neeraj.
Yeah,
Thanks for a wonderful session. I have two
thank you.
queries.
Yes. Yeah.
One, you had mentioned in the beginning that for Linux monitoring, we need to execute a separate process to monitor it. If I'm running my application server on same box, so can't we get all the stats like CPU utilization, disk space, and other stuff using the same library?
Yeah. So, are you saying about the Linux, right? Linux.
Yeah, Linux. Yeah, for Linux.
Yeah.
Yeah.
Yeah. So for that, there are node exporters which you will have to which you will have to run to monitor the Linux hardware.
If I want to avoid running node exporters as an additional process on a Linux box, is there an
Yeah.
alternative? Like, for example, Java, Golang, libraries are already there. So within using Java library or Python library itself, I can pull the metrics related to box also, right? Linux box.
There will be a library. You can write your custom code to export the metrics from Linux. Yes, but if you want to go on, I mean, if somebody don't want to go in that deep, I mean, low level programming, then there are node exporters available which does the job for you. But yes, there is an option.
Right. And is there any way to limit the number of whatever data we are sending? For example, now I saw as a default, we are sending a lot of metrics information. But if I want to just limit to a specific element to, save on some bandwidth issues or
Yes, yes,
save some
yes. You
bandwidth.
you can yes, we can do that. So basically, what you're asking is at the moment, if I'm running this, I only interested in product, right? I'm not interested in
Correct.
other things. So yes, we can disable this. We can disable other Go specific metrics. We can do that.
Perfect.
Yes,
Thanks.
yes. Right. Yeah. Any other questions? I'll show you. If not, then I'll show you one more. There is one more interesting library called Telegraph. Telegraph. I'm not sure how many of you heard about Telegraph input plugins. So basically it works on plugins, input plugins, output plugins, and exporter. So basically it collects the metric from system devices or third-party APIs. It processes the plugins and output plugins. So basically there are various input plugins available to read uh, that data from, and then you can have output plugins. So you can tell Telegraph to produce the output in Prometheus format, which is very interesting. So there are a lot of uh, plugins available, and you can have a look. I'll just show you. There are very interesting plugins available, which I was talking about.
Neeraj, if
Yeah.
there is any issue, for example, SIP utilization is high, or there's some issues on the threads or something, so we usually go with app dynamics or Dynatrace kind of
Yes.
tools where to analyze the issue, troubleshooting the problem.
Correct.
So
Correct.
this is Prometheus would only give the notification that there is something went wrong. How, what went wrong, or what exactly is the root cause of it? That I think I will need a separate tools to monitor or investigate. Correct?
Yes. So you can use Grafana also for that. So you have, let's say, I was showing right in Grafana, you can uh, it shows it can show you the issue where it has occurred, and sorry, it can show you the issue which has occurred. This is simply we're running this about request time, but if you look at some other options, you can set up this to, you can add a threshold here, and based on the threshold you can set up the alerts.
I was wondering around, CPU high heap memory usage or CPU or thread deadlocks situation and
Yeah,
all that.
yeah, yeah. Yes, yes. So, yeah. So I think for that, once you know it CPU is going high or there is a issue with memory, yes, you will have to use. Now you know where is the problem is, and that which node or which container is creating problem. You can have. Yes, you're right. We will have to. I mean, exporting the heap dump is you have to use some other tool. Exporting heap dump, analyze the heap dump.
Right, right. Okay,
Yeah,
cool.
correct. Okay. Any questions? We're just on time.
Yeah, one more thing. You are showing that how we monitor the routers at the home.
Yeah. You want to see that? I was not finding that. What is that? I'm just trying to see the input plugin. Matrix plugins, inputs. Yeah, so these are the input plugins available. If you look at it, there's a lot of input plugin. If you look at go here, SNMP, network, internet speed. So you can use internet speed plugin, or you can use there are you can also have Kubernetes plugin. You can have Kafka plugin also supported. I think here MongoDB, net response, right? So let's say net response or net state, network input plugin. So you can have this plugin. So basically you need to run a telegraph image, and then you can tell telegraph to export the metrics in Prometheus format, and then you can straightforward monitor it. This is very rich library. I think people have been using it. Uh, so it response would look like this, something like this. So what is the result and time series database?
So we have to run this telegraph on the router.
Yeah. No, not on router. On as a Docker image on your container, and you will need to configure it where your router configurations on
Okay,
this. Yeah, there is a configuration. You need to tell about your address of your router and etc.
okay, understand.
Yeah, yeah,
So, Neeraj, just a quick question, follow-up on this. So, Telegraph, I'm just trying to understand how it fits into this entire monitoring ecosystem. So, uh, uh, when we say Prometheus can actually directly scrape the metrics from the application itself,
yeah.
why or in which use case would we really need Telegraph? Would it be for apps which are not?
Yeah, so yeah, that's a good question. So let me give you example. Kafka. So let's say you want to monitor the Kafka, how it is performing, right?
Mhm.
So uh, uh, y- uh, I mean, either you can write your custom code to export the metrics, or you can use such library Kafka consumers or Kafka legacy. So if you look at the Kafka consumer input plugins, so you can just configure Telegraph to tell what is your Kafka details, right? And then it will like just it will just do the job for you to monitor your Kafka health,
Oh,
like
okay,
that,
got it.
like that. So there are various plugins available. So it based on plugins, input plugins. You can just uh, configure based on your need.
Right. So basically, Telegraph is then going to sort of poll the application, which is Kafka in this case, and then export those metrics, relevant metrics to Prometheus. If we have an output as a
No, it
Prometheus.
will not. You will tell Prometheus to I mean, you will tell Prometheus where is your uh, telegraph running,
Okay,
right? And telegraph is configured with this guy to pull the to have the metrics with him. So
got
there
it.
is a
Okay,
configuration. So the way we are putting this endpoint here, in the same way you will put telegraph where your
Telegraph
telegraph is
and
running.
run.
Yeah,
Got
correct.
it. Got it. Okay. Thank
Yeah,
you.
no worries.
And sorry, just a quick follow-up. And I suppose we can have multiple targets
Mhm.
that Prometheus can pull the metrics from, right?
Yes,
Like
yes, yes,
static
yes, very
config is
much.
one. Okay.
Yes, yes, very
Another
much.
one
Yes,
could
we
be,
can have multiple job names here. So, for example, I'm one job, we can create multiple job names with multiple targets. So it will just keep on pulling the metrics from multiple targets.
okay, yeah, that's understood.
Yes,
Okay, cool.
yes.
Good, thanks.
No worries. Thank you. Cool. Any other questions?
Yeah, I think we are good, Neeraj.
Good. Okay. Cool. Thanks. Thanks, Om. Over to you.
Yeah. So first of all, thank you so much, Neeraj, for
No
taking the.
worries.
Yeah, I think it was really great session. I think the demo really helped me understand better. So yeah, thank you for that.
Thank you. I'm glad. Yeah.
Thank you all for joining. I mean, just check out. I've shared the link. If you're willing to, participate and be one of us, please reach out. And if you wish to conduct any session on any given topic, yeah, that is also very much welcomed. And yeah, thank you for your time. Have a good evening. Yeah, thank you all.
Thank you.
Thank you. Thanks, everyone.
Thank you.